Kinematics is a study of motion of a body and the rest of the body. So it has the two divisions. One is the statistics, another one is the dynamics. Dynamics is the study of motion of an object, and statistics is the study of that body is at rest. Okay. So now we are going to see that kinematics, initially that measurements are used to measure the very smaller things and very greater things. So 2300 years before Euthydemus, he discovered that the size of an atom, he measured the diameter of the earth. But after a very long time, the near 20th century only, we measured the size of an atom. So we measured a very big thing, but it takes very lot of time to measure a very small thing, that is atom. Okay, 20th century only we measured that. So how the object is moving and how faster it's moving. So we can define the motion of an object, faster, average, slowest, like that. So depending on the time period and the displacement of the particle, we can classify the 5 categories. So here we are going to study about the motion of an object, right? So in that lesson, we are going to analyze the motion in terms of direction and magnitude. Okay, that is the two basic things. In this lesson, we are going to see about that. So next one is the rest and motion. So now we are going to see that what is meant by rest and motion. So rest and motion. The concept of rest and motion, that body is said to be at rest. It does not changes its position with respect to its surroundings. That means time. Okay. So if a body changes its position with respect to its surroundings, then the body is said to be in motion. So continuously it has to change its position for time period. For an example, you can take that the book is at rest with respect to the surroundings, right? So suppose any force is acting on that object, it will change its position. Up to that, it will stationary. But it depending on that sun, if that book is not in a stationary, it's depending on the earth only, it is in the stationary. But depending on the earth, it is in the motion because earth is revolving around the sun. So we concluded that book is motion with respect to the sun, right? So next thing, you can take an example. Let us see a person traveling a train and passes another person standing along the side of back. So see the two different views. The person standing on the track will see the person, and everyone else, the train as being in motion. Okay. At the same time, but all the persons sitting in the train will be stationary with respect to each other. Suppose train குள்ள இருக்கிற ரெண்டு பேர் ரெஸ்ட்ல இருக்கிற மாதிரி இருக்கும், but outside is in the motion. That objects are in the motion. So you can consider the two objects, object A, B, and another one is C. So an object may be in the motion with respect to other object, but may be a stationary with respect to the third object. That is object C. Right? So according to that, A and C is motion, but in relation to B and C is stationary. The two persons are sitting inside the train. They are like that. They are in the rest position, but the object in the outside the train, they are moving with a velocity. So it is a concept of rest and motion. So here we are going to define that. How we can define that motion of an object with velocity and the magnitude direction. Right? Next thing, that motion it has a different type of motion. You have studied in the lower classes. Okay, so different type of motion, you know that the different type of motions are that all the motions are with respect to time. We have classified that. So with time only we can classify all the motions: uniform motion or non-uniform motion, oscillatory motion, whatever it is. So motion can be compared to related to the some things. That means with the reference points or time period. Say that object is moving, that a man and the tree is not moving. That is stationary. Okay, it's depending on the earth. But in earth is rotating. Okay, it's revolving around the sun about an axis. So a person which is seeing in the outer space. For example, he is in the outer space. near like a moon. So astronaut seeing that man in the moon, that man under the tree is in the motion. So we have to define the position of an object which is in that rest, that coordinate axis, by using the coordinate axis. Perspective, that means how we are looking that object from the earth or the outside that earth and how it is moving. So see that on seeing that two objects from the in the earth, it is in a stationary, but outside that earth it is in that motion, because earth is revolving around the sun and it is rotating about an axis. So axis means you can see that the Cartesian coordinate axis, that is x, y, z axis. So we can define the position of an object, that's called inertial frame of reference. So with the frame of reference, we can define the position of an object. The two type of reference are inertial frame of reference are there. That can be classified into the coordinate axis, right-handed coordinate axis and left-handed coordinate axis. Writing that x, y, z axis in a clockwise direction or in a anti-clockwise direction. Right? So now you can see the two friends are moving in the car. So that objects are on the outside that car is look like a moving, but the man, see that man is sitting there. So he is seeing the car, so it's in that motion. The respective time, it changes its position. So motion is relative. It's related with the surroundings. So another example you can take that the different motion, different types of motion. So suppose you are seeing that activities in that park, then how they are moving. We can classify that into different types. So now we are going to see the types of motion. A man is running on the straight track. So he is moving from one point to another point. The straight line is called rectilinear motion. Example of rectilinear motion is light comes from sun, bulb, or the outer space. Always travel along a straight line. So this type of motion is called rectilinear motion. That ball is thrown from that one end to another end. It's not a rectilinear. That ball is moving in a curved path. So this type of path is called curvilinear motion. So travels along a curve. Okay, so this is called curvilinear motion. The next one is that is also another example for the curvilinear motion. It is not a straight line. That ball is moving curvilinear path. So this is also example for the curvilinear motion. So rectilinear, curvilinear. Third one, so you can see that first 5 athletes are moving in they are running in the track. So 3 athletes are reaching at the destination the same time period. So it's called same time, same distance. They are traveling in the same distance. So this type of motion is called translatory motion. So translatory motion. So here that 2 translatory motion, 3 athletes are reaching in the same time period. Next one, you can see that wheel of the cycle and car, they are moving a circular motion. So this type of motion is called rotatory motion, or circular motion. Okay, circular motion, these are all another example for the circular motion, right? Next one, oscillatory motion, or it's called vibratory motion. If an object or a particle executes to and from motion about a fixed point, is said to be a vibratory motion. This is sometimes also called oscillatory motion. Okay, that oscillatory motion example is a simple pendulum. So pendulum in the clock. Okay, that is increase the oscillation rapidly. You can increase the oscillation. It's called vibratory motion. When you are increasing that oscillation, that's called vibratory motion. So example for the vibratory motions are these are the example for vibratory motion. Periodic motion. Periodic motion, body repeats its motion, whatever it is, after regular or constant interval of time. The type of motions are called periodic motion. So body repeats its motion after a regular or constant interval of time, called periodic motion, or it's called uniform motion. So uniform motion and non-uniform motion. The uniform motion is a body repeats its motion of a regular interval of time is called uniform motion, right? So these are called different types of motions. So example for the uniform motion is uniform circular motion. Earth is moving in a sun. Earth revolves around the sun. That's one example. So see that it's not a uniform. Sometimes you are faster and slower. So it is not a regular or constant. So this type of motion is called non-uniform motion. Called non-uniform motion. So example for non-uniform motion is see that the particle is not moving in a uniform velocity. It is traveling at different velocity. So these are called different types of motions. Okay. So different type of motions. So these are all the things we have seen in that slide.